Okay, so number one on the review packet, all it's asking is what is happening to the formula or what's happening to the equation, okay, to the function. So you just have to describe it. So for example, for this one here, right, the -2, right, that just says you're going to move to the right 2, okay? The 3 here says it's going to stretch by a factor of 3, by a factor of 3. Okay. And then the negative there, if you look in the graphing techniques, the negative in the front, it just means it's going to reflect about the x-axis. Okay. Uh, down here, um, the -4 is going to tell us it's going to go down, right? It's going to go down by 4. The minus x tells us that it's going to reflect by the y-axis, okay? And then the 1/2, okay, is going to compress it. Compress by a half, okay? Okay, so this question, they want us to find the domain, range, and asymptote of the given function. So again, it's so vital to understand what the graph is doing, right? So if we were to draw the parent graph of the original function, right? So we have y is equal to log of x. So it's, going to do um, something like this, right? That's what the log of x is saying. So when we look at this function, um, we want to focus on the x, okay? So we're focusing on this, right? Because that will tell us the domain, okay? So remember, if again, if you try to put any number that is 0 or less, it's not going to work, correct? If you put log of 0, it'll give us an error. Log of -1 will give us an error. Okay, so that's why you want to focus on x and set that to greater than 0 to find the domain. Okay, so I'm going to do exactly the same thing here. I'm going to focus what's inside the parentheses, pull that out, and then I'm going to set it to greater than 0, then solve. So that gives me +1, +1. Okay, so that gives us x is greater than 1. And that's my domain. Okay, because again, if I put any number in there that's going to make it 0 or negative, it's not going to work. But if I pick a number that's greater than 1, it will work. Okay, and then in regards to the asymptote is going to be exactly the same thing as what you got for the domain. But instead of x is greater than 1, it would just say x is equal to 1, and that's it. So whatever number you get for the domain, it will always be the same for the asymptote. Okay, because again, this is saying it's moving to the right. It moved to the right by 1, right? It moved to the right by 1. It's always the opposite where you think, even though it says negative there, we're going to go to the right by 1. Okay, so that means there is an asymptote at 1. And in regards to the range, all right. So again, if you look at the original function, it goes forever in the negative direction and forever in the positive direction. So for the range of the original function, it's all real numbers. It's -infinity to +infinity. Well, it's the same thing for this one. So even though I moved to the right and I went down 4, I'm still going to have the same type of shape. Okay. So my range is still going to be from -infinity to +infinity, always. Or I can just say all real numbers. Again, this only works when the inside the parentheses is a power of 1. Okay? And that's what we want to focus on, right? Okay, so this question is talking about the composite function. So remember when we covered this, we talked about the nesting dolls, so that it's one doll. When you open it, there's another doll in it, so it's embedded. Okay, so that's what we're basically doing. We're going to embed one function into the other into the other function. All right, so in this case, it says f circle g of x, or f of g of x. So this, we work inside out, right? We work inside out. Okay, so we're going to focus on the g of x. So what is it saying? It wants us to take g of x, so which is 2x plus 3, and we need to plug it in for f of x, or in this case, x. So anytime I say an x, I just replace it with 2x plus 3. So I have f of x is equal to x squared plus 5, and then I see that x, so I need to replace it now with 2x plus 3 raised to the second power of 5. Okay, and then I just simplify. So I have 2x plus 3 times 2x plus 3 plus 5. Okay, so I can do the for method and multiply that out, or I can just do a little trick here where I can square the front. So that's going to give me 4x squared. Square the back, which gives me 9, and then multiply the 2. So 2x times 3 is going to give me 6x, and then double it. So that'll give me 12x plus 9. Again, if you don't feel comfortable doing that, you can just, boil it out. Okay. All right, and then we still got the plus 5 here. So we just add those guys together and we get 4x squared plus 12x plus 14. Okay. If you want to factor out 8, 2, that's fine, or you can just leave your answer in this form. Okay, so if you see this type of problem on the exam, so remember the average rate of change is the same thing as the slope formula, which is y2 minus y1 over x2 minus x1. But they just write it a little bit differently, and they say, f of b minus f of a over b minus a. All right. So in this case, our f of b and f of a, that's going to come from these points here, right? So we have this function, h of x is equal to x squared 7 minus 7x, and they want us to find the average rate of change, which basically is the slope formula. We're going to go from 8 to 9, okay? So I'm going to find out what f of 8 is, and then f of 9 is. So I'm just going to plug that information into my function. Now I'm using f, you can use h, it doesn't matter, it's the same thing, okay? All right, so we'll have 8 squared minus 7 times 8, and when we do that, we should get 8 as our answer. And then for f of 9, we get 9 squared minus 7 times 9, so that gives us 18, okay? So now I know what my f of b and f of a are. So again, this is my f of a, and this is my f of b. Okay. So f of 9 minus f of 8 over 9 minus 8. So f of 9 was 18. F of 8 was 8. And then 9 minus 8 is 1. So 18 minus 8 is 10, divided by 1 will give us 10. So that's the average rate of change, okay, is 10. Okay, so the next part is asking for the equation of the secant line. So we can use either y is equal to mx plus b, or we can use y minus y1 equals m times x minus x1. So my preference is the second one. It's just, for me, it's a lot easier. I just plug it in and I'm done. Okay, so so in this case, so here it says using this point here. So 8, right? That first one, when x was 8, what was when we plugged it in? Well, we got 8. All right, and 9, when we have 9, when we plugged it in for the function, we got 18. Okay, so that's what this is coming from, right? When it says when 8 is, what happens when you plugged in 8? Well, I got 8. What happens when you plugged in 9? I got 18. Okay, so you can use either one of these points as your x1, y1. Okay, I like to choose the ones that are the lowest numbers because they're easier to calculate. So I'm going to pick this as my x1, y1. Okay, so then I just plug it in. So y minus 8, m is this, right? That's my slope is 10. And then x1 is 8. All right, then I just distribute. So that gives me 10x minus 80. Then I'm going to add the 8 on both sides. So y is equal to 10x minus 72. Okay, so this is the equation of the secant line.